Hey guys, Miss Amy here. We're going to cover Module 11 for chemistry class since we have a snow day. We actually reviewed almost all of it last week, so we're in good shape, and I'm just going to quickly go through the main points so you know what to study for before you take your test. Of course, since we're not in school this week, I'm not going to be strict on having your homework next week, but we are not altering the schedule. So if you have a question on the chapter, you don't want to take your test till after you've gone through it with me, that's fine. You can turn it in late, but don't just stop progressing through your homework. Keep going as you can, because we're just going to keep moving through the module as our schedule shows, because if we don't do that, we won't finish till like late spring, well after co-op has ended. These are just the major terms you should know in case you realize you've kind of forgotten some of them. You know what to go back and study before you take your test. Solute, solvent, solution, solubility, saturated, all the fun S words. We also did endothermic and exothermic reactions. You should know what that is both on the molecular level, but also just the big picture. What are you going to observe if you're in a lab and you combine two things that give you either an endothermic or exothermic reaction? Talked about freezing point depression and boiling point elevation, and how to observe, or I'm sorry, how to calculate those. And from previous chapters, you definitely still need to remember the difference between ionic and covalent bonds, and specifically polar covalent and purely covalent. While we're here, I want to remind you, since we talked about freezing point depression, 11.4 lab you were originally scheduled to do from home anyway, since you're just standing around waiting for something to freeze. Make sure you get that done. And then the 11.3 lab I sent out an email about when we knew the weather was going to be pretty dicey. Instead of trying to find lye, you're welcome to do that, but instead of trying to do that specific exothermic reaction, pick any endothermic or exothermic reaction your parents are comfortable with you doing at home, and just adapt the lab accordingly. So you could do water and Epsom salt, yeast and peroxide, baking soda and vinegar. There's a lot of choices. Just Google them, pick one, and adapt the lab. The one thing I did point out was whatever you use, make sure all your supplies are out and sitting in the same area for at least an hour, so you know they're all the same temperature to start with. Otherwise, that could mess up your results. All right, when we're dealing with solute and solvent, make sure you know which is which. There's a couple examples, but there could be more, but carbonated water, you've got gas dissolving into the liquid. And with salt water, you've got a solid that's dissolving into it. Of course, you could have two liquids as well. There's a lot of different ways to make solutions. Know your solubility factors. Most of these are on page 362, but just read there in the surrounding areas. Depending on what state of matter you're dealing with, solid, liquid, or gas, temperature and pressure have different effects on solubility. Know the difference in how ionic and polar covalent behave when you are making solutions. Ionic, they're going to dissolve into its two ions or more ions, but there's going to be two types, positive and negative, and the water molecules will be attracted to each of those as is appropriate, depending on the sign, will affect which part of the water molecule is attracted. Polar covalent will not split up. Water molecules can still be attracted to it. However, it will be, they'll just have to orient themselves as best they can, depending on what part of the molecule they are closest to. All right, and one final problem I want to work to make sure we've kind of covered everything. We have a solution made of 100 grams NH42S with 750 grams water. So what do we know? We want to know the boiling point. What did they tell us? Well, our solute is what we are mixing, that's 100 grams, and our solvent is what it's being mixed into or with, and that's the 750 grams. So we've got the mass of both of those. We want to find boiling point. So what equations do we know? Boiling point is going to be whatever the original boiling point is plus the elevation, the delta T. Delta T is determined by I K sub B M, and K sub B for water. It changes depending on your substance, but our solvent is water, so K sub B is 0.512 degrees Celsius per molality. And finally, molality is number of moles of solute over number of kilograms of solvent. So that should give us about everything we need to know. Let's start working. Let's look at that delta T, and we already know K sub B, so I'm going to plug that in there. So now I know that delta T is I times the 0.512 degrees Celsius times molality, per molality times whatever our molality is. Now I want to figure out I. That's the easiest one. It's how many chunks does that solute split into when it dissolves. In this case, it'll be 3. Remember, the answer can be 1 if you're dealing with something that's covalent. So we have 3 ions, 2 of the NH4 and 1 of the S. So now it's 3 times 0.512. We're still waiting on molality. So to determine molality, we need moles of solute and kilogram solvent. Kilogram solvent is the easier one. Let's do that. We got 750 grams, which is mass, but we need it in kilograms. So we just need to multiply it by that special fraction, which is equal to 1. So it does not change the overall value, but it does change its looks, its units. We want to get rid of grams, so we put grams in the bottom. We want to end up with kilograms, we put kilograms in the top. And what numbers can we use so the top is equal to the bottom? Well, if we've got kilograms and grams, that is 1 kilogram is equal to 1,000 grams. So that's our special fraction, 1 kilogram over 1,000 grams. Multiply that by 750, and you end up with 0.7500 kilograms. Moles of solute is a little more complicated or fun, depending on how you like to look at it. We need to go get some AMUs to figure out what the molecular mass of our molecule is. Remember, it's 2 of those NH4s, so we got to double everything in there. So we have 2 N's, 8 H's, 2 N's, 8 H's, and 1 S. So you figure that out, it should hopefully be 68.2. And what does that mean? What that means is 1 mole of those molecules has a mass of 68.2 grams. So now we know that, and we know that we're starting with 100 grams of it. We can convert that into moles. So since we're starting with 100 grams, we want to convert into moles. We need that special fraction that's equal to 1. That'll let us keep the same overall value but change the looks. So we want to get rid of grams, so we put grams in the bottom. We want to end up with moles, we put moles on the top. And what numbers can we use so that fraction is equal to 1? That means the top and the bottom have to be equal to each other or equivalent. And so 1 mole is equal to 68.2 grams. And those are the numbers we use. So 100 grams turns out to be 1.47 moles. Now we know moles of solute, we know kilograms of solvent, we can plug that in, and we get 1.96 molality. Now that we know all of that, the molality can be plugged into our delta T equation, and we find delta T is 3.01 degrees Celsius. We just take that, add it to the original boiling point of water, which is 100, and our elevated boiling point is 103.0 degrees Celsius. All right. That is Module 11 in a nutshell. If you have any questions, feel free to text or email me during the week. If not, I will see you in class next Friday, and we will keep going at that point. I hope you're enjoying your snow day. I'll see you next week. Bye, guys.